Hello students, welcome to my YouTube channel and welcome to the topic of integration. In this particular video session, just we are going to discuss further about the integration by parts method. In the previous video session of integration by parts method, just we have discussed about the formula and some of the basic problems. In this particular video session, just we are going to discuss about more on the integration by parts method. So here, I am going to evaluate the integral of square root of a square minus x square with respect to dx. So let consider I is equal to this integral of square root of a square minus x square with respect to dx, and you can see that this integral contains a single function, but integration by parts is based upon the multiplication of two functions, so there is not the second function. So consider, or we can express this function as the multiplication of square root of x square minus x square with 1 dx. Then we can consider the first function and second function. Here we have to consider the first function as square root of x square minus x square and second function as 1. Then by applying the integration by parts method, here we have integral of 1 with respect to x, it is x multiplied with square root of a square minus x square minus derivative of square root of a square minus x square can be solved by using the chain rule of derivative. So it is 1 upon 2 multiplied with square root of a square minus x square, again the derivative of a square minus x square, and it is minus 2x into integral of 1 dx, 1 with respect to dx, then it is x. Then simplifying this step, we have then it is minus x square whole divided by square root of a square minus x square dx. Then adding a square and subtracting a square in the numerator part, we have then again simplifying this term, we have then separating these terms, we have then by putting I in place of square root of integral of square root of a square minus x square dx, we have then Then shifting this I term towards the left hand side, we have I plus I, then it will be 2I then I will be equal to x by 2 a square minus a square, square root of a square minus a square plus a square by 2 sin inverse x by a plus c1 divided by 2. But we know that the value of I is integral of square root of a square minus x square dx, and it will be x by 2 square root of a square minus x square plus a square by 2 sin inverse x by a plus c. So here it is the answer for the integral of square root of a square minus x square with respect to dx by using the integration by parts method. Then let us prove this formula again by another method, and also you can say that alternative method. Integral of square root of a square minus x square dx. Here we have to assume let x is equal to a sin theta. That implies dx is equal to a cos theta d theta. Again, as we have known that a sin theta is equal to x, then sin theta will be equal to x by a, then theta will be equal to sin inverse x by a. Here it is another assumption. Again, a sin theta is equal to x, that implies sin theta is equal to x by a. It is another assumption. We know that cos theta is equal to square root of 1 minus sin square theta. Then it is 1 minus square root of 1 minus whole square of x by a. Then it will be 1 minus x square by a square, and it's the root over. Then it will be a square minus a square divided by a square, and it's the root over. That implies cos theta is equal to square root of a square minus a square whole divided by a. So this is one value, this is one value, and this is one value, and this is one value. These four values are required for our problem. So by putting these values here, a square minus a square sin square theta, in place of dx we can put a cos theta d theta Now simplifying, we have a cos theta multiplied with a cos theta d theta. Then a into a, it is a square, it is taken towards the outside of the integral process, then it will be a square multiplied with the integral of cos square theta d theta. In place of cos square theta, we can put the formula 1 plus cos 2 theta whole divided by 2 d theta. Then by simplifying this step, we can have a square by 2 integral of d theta plus a square by 2 integral of cos 2 theta d theta. Then it will be a square by 2 theta plus a square by 2 integral of cos 2 theta d theta, it is sin 2 theta whole divided by 2 plus any constant c, then it will be a square by 2. In place of theta we can put sin inverse x by a plus a square divided by 2. In place of sin 2 theta we can put 2 sin theta into cos theta whole divided by 2 plus c, then cancelling both of the 2's from numerator and denominator. Then it is a square by 2 multiplied with sin inverse x by a plus a square by 2. In place of sin theta we can put x by a. In place of cos theta we can put a square root of a square minus x square divided by a plus c. Then it is a square by 2 sin inverse x by a plus cancelling both of the a with the numerator a square, we have x by 2 multiplied with square root of a square minus x square plus c. Hence, integral of square root of a square minus x square dx, it can be written in the form of x by 2 square root of a square minus x square plus a square by 2 sin inverse x by a plus any constant c. And here it is the proof. Then let us discuss about some of the problems based upon this formula. So here it is one of the problem based upon this formula. First of all, we have to express these terms in terms of a square minus x square. So it will be integral of square root of 3 square minus x square dx, such that here in this place a we have 3. Now we can put the formula directly. So it will be x by 2 square root of 3 square minus x square plus a square by 2 multiplied with sin inverse x by a, that means 3 plus any constant c. Then by solving it we can have x by 2, it will be 9 minus square root of 9 minus x square plus it is 9 by 2 sin inverse x by 3 plus any constant c, and here it is the solution for this problem. So particularly in this video session, just we have discussed about one of the method based upon integration by parts method. In the next video session, just we are going to discuss about another method based upon it. Till then, thank you.